Hey guys, we got a fun day ahead of us. We're doing 2-2 day one. We're talking about basic differentiation rules. All right, we've been talking about this for a while. We've been knowing it's coming. We're going to finally learn the shortcuts to deriving functions. All right, so this whole lesson we're pretty much going over all the rules and we're going to do different examples for them. So let's get going. Let's start off with our constant rule. All right, all that's telling us, and this is the same for a lot of things, is when we derive a constant, okay, remember this is one of those symbols for taking the derivative, right, d over d of x. When we take the derivative of a constant, it's always going to equal 0, okay? So that's going to come in handy when we have those big polynomials we might be taking the derivative of, and then it's like at the end, usually you have that constant. You can just wipe that out right away, okay? So let's look at some examples for this. I mean, as you see, we're taking f of x of 5, right? So if we take f prime of x with the derivative of x, it's going to equal 0. Okay, same for 2. 3 times pi squared, right? Pi is a constant. Okay, so we got f prime of x equals 0 for both of those. All right, that's the easy one. Okay, now the power rule. This is the trick right here, the power rule. All right, as you can see, all that's happening right here when we take the derivative of x to the n, okay, this n, all you're going to do is go pop it down in front, as you can see, right? We pop that n in front, and then you subtracted 1 from the exponent. Okay, if you're thinking about it in terms of f prime, this is what it looks like. But again, all we're doing, taking that exponent, putting it down in front, and then subtracting 1 from the exponent. So let's think about that. Let's write a proof for that real quick. We're gonna do it the way that we did our like difference quotient. All right. So we're proving that f prime of x to the n is what we said is the power rule. We're writing the proof for it. So we're going to do f prime of x equals the limit as delta x goes to 0 of x plus delta x to the n minus x to the n, right? This is stuff we've been doing the past couple sections, over x. So we're just going to take the limit of this. Okay, so our next line, we have delta x goes to 0. All right, and we're going to expand this out. Okay, and the way we're going to expand this out, we're writing it in all the different terms of n. So we're going to write it for n minus 1, n minus 2, and so on and so on and so on. So it's going to look like this. And then we'll just skip some of that because we know it's just going to plus nx n minus 1 plus delta x to the n minus x to the n. Okay, there it is. Okay, so from here, again, we can cancel out a bunch of our mumbo jumbo. It's pretty much all, it's just those x's to the end. We got a negative and a positive. So our next line, we're going to combine all our like terms now. Oh wait, and all this, don't forget, is over delta x. Okay. N to the x to the n minus 1 plus n minus 1 over 2 x to the n minus 2 delta x plus blah 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 n x n minus 2 plus delta x to the n minus 1. That's a big parenthesis. Okay. And as you can see, when we start plugging in our 0 for our delta x, right, when we start plugging in zeros right there, our final result should leave us, right? Oh yeah, because that's all connected. Okay, our final result should leave us with nx n minus 1, right? Because this 0 is going to cancel out all that stuff, and you're going to be left with just that term in the front. Okay, remember when we're doing all that difference quotient stuff, that's what it all comes down to. If we expand it out, we combine like terms, and we cancel everything out. So, as you can see, that's what we get. It's proven. If you want more examples, there are tons of proofs of this, okay? Like I said, I always encourage you guys to go watch as many videos of this stuff as you can. The more you understand Calc 1 before you go into Calc 1, the better you're going to be, and the better you're going to be going into college. Okay. So, examples. We're going to keep moving through some examples, just talking about different situations and what they look like, okay? Because that's the best form of practice, is doing as many examples as you can. Again, I suggest you go find more examples, videos to watch that help you with this. So, number 1. All right, we're going to find f prime of x. We're going to take the derivative of f of x. We have x to the third. So, right, our powers shortcut tells us that we're going to take that 3, put it in front, and subtract 1 from our exponent. Okay, for 2, we're going to do the same thing. We're going to top pot that 6 in front, subtract 1 from the exponent. You're left with 6x to the 5th. Okay, we got a cube root here. Don't let that confuse you. Remember, that's the same thing as x to the 1/3. So when we do our derivative, okay, we put the 1/3 out in front, and we subtract 1 from 1/3, right? And 1/3 minus 1 is negative 2/3. Okay, write that in even simpler form. No negative exponents. All right, right here. Look at that right there. All answers should be in positive exponents. So we toss it underneath. Okay. 4. We have 1 over x squared, which I do this every time. It's always easier to put that exponent up there. All right, make that a negative exponent. Then when you take the f prime of x, get the negative 2 out front. Remember, negative 2 minus 1 is not the next page. Is negative 3. Okay, remember we got to make it all positive exponents. Negative 2 over x to the third. Okay. Now we're going to talk about the constant multiple rule. Okay, this isn't too bad. All they're saying here is that if you have this constant multiplied by a function, you can just pull that constant out front before you do the derivative. Okay, so you just have the constant multiplied by the derivative of the function. All right, we're just pulling that constant out front. So then it's just the constant times the derivative of the function. All right, what do you know? We got more examples. So example 1. Find f of x. Okay, find the derivative of 3x to the 4th. So, again, remember that 3 can be pulled out front. We can pull that out front, we just add that on to the end. So we're really just taking the derivative of x to the 4th. So if you take the derivative of x to the 4th, right? You're going to put that 4 in front, 4x to the third, and just put that 3 out front. Okay, it's going to equal 12x to the third. All right, 2, we got a negative 2, so we're going to put that negative 2 out front. Take the derivative of x to the third, and we multiply it out. Negative 6x squared. Okay, moving on to 3. We got, you could think about this as the same thing as 1/5 x cubed. Okay, so when we take that derivative, pop that 1/5 out front, all right, times 3x squared, you're going to get 3/5 x squared. Okay. Looking over at 4, we have, okay, so remember, this is the same thing as 1/3 times x to the negative 1/2. Okay, remember, always write that in terms that we can work with. So when we take the derivative, we have our 1/3 out front. We're going to be when we, hold on a second. All right, so when we take the derivative and we subtract 1 from our negative 1/2, we're going to be left with x to the negative 3/2. And then that negative 1/2 that we're pulling down there, multiplying it by 1/3, it's going to give you negative 1/6. Remember, we can't have negative exponents. So the best way to write this, or the way I wrote it, is negative 1/6 x to the 3/2. All right, you could also write that in terms of, it could also be 6x times the square root of 3. Or the cube root, or square root, sorry. Okay, yeah, so that's your answer. So on to 5. 5, we got to look at that. Remember, this is the same thing as 3x to the 1/3. Okay, let's go do our power rule. It's going to equal 1 cube root of x squared, which equals 1 over x to the 2/3. Okay, these aren't too bad. Just a lot of practice recognizing certain situations is the key. So now 6, all right, that is the same thing, right? If we simplify those constants, that's the same thing as negative 2x to the negative 4. Okay, so f prime of x, we got 8x to the negative 5th, which equals 8 over x to the 5th. Remember, no negative exponents. No negative exponents. Okay? Now, we're going to look at the sum difference rule. Okay, all that's saying, as you can see, if you take the derivative of two functions, it's the same thing as adding their two derivatives after the fact. Okay? So you can either add them before, you can add them after. This can be distributed. So examples, let's hop right in. Number 1, all right, if we take f prime of x, all right, we do it to both parts. So we can take the derivative for both parts. The first one comes back 4x to the third. The second one comes back just 12, right? Because that's the same as 12x to the 1. So we put the 1 out front, leaves you just the 12, and then you subtract it, and x to the 0 is 1. So you're left with 12. Okay? That's the key one, all right? That's what makes it real nice whenever you just have, a constant times x, just x, no exponent, you know it's always just going to be that constant in the end. 2. So we're going to do the same thing, just kind of integrate it, break it up into its little parts. First one, x cubed turns to 3x to the squared. 3x squared turns into 6x. And 5x turns into 5, and 1 disappears, right? That turns into 0. All right, but you don't need to write that. Turns into 0. That's your answer. Okay, for 3, remember this is the same thing as negative 1/3 minus 3x to the negative 2. So when we do this, take our derivative, get 6x to the negative 3, which is the same thing as 6 over x to the third. Okay, moving on to 4. All right, I like to expand this out first so I can see what I'm working with. We have 9x squared minus 12x plus 4. That's what you should get when you expand that guy out. So when we take the derivative, we're going to be left with 18x minus 12. Right? That constant 4 disappears. The 12 just is left by itself. And the 9x squared turns into 18x. Hopefully you guys are feeling comfortable with this stuff. Again, you have my contact information. Reach out if you need help with anything. Now, everybody's favorite, sine and cosine functions. Okay? There's a real easy trick with this. All right? Sine goes to cosine. Cosine goes to negative sine. All right, there's a weird way I think about this. I don't know if it'll help you guys. If not, whatever, find your own thing. But I think about the alphabet as like, you know, if you think about writing the alphabet vertically, you're just A, B, C, D, E, you know, so on, S. Okay? I think about it as when I'm going S to C, right? S to C right here. I got to go positive, right? I got to go up. I'm adding to it. It's positive, so my C is positive. Okay, when I'm going from C to S, from sine to cosine, I got to go down, so my sine's negative. Okay, that's kind of how I think about it. It's a weird way, but it's just stuck with me this whole time. Okay, so the derivative of sine, cosine, derivative of cosine, negative sine. So let's look at some examples now. Number 1. Okay, we're going to take the derivative of 2 sine of x, right? Constant stays out front, leaves you with 2 cosine of x. Now for 2, we got 3x, we got a couple pieces to this one. First one's going to leave you with just a 3. 3x turns to just a 3, and going from cosine of x, it's going to give you, the negative sine of x, right? Cosine to sine leaves you cosine, goes to negative sine, sine goes to positive cosine. Okay, 3. From here, our cosine is going to go to negative sine. All our constants stay the same, except for the derivative of the constant itself, which disappears, so you're left with negative sine of x over 5. 3's gone. For 4, when we take the derivative, we will be left with a negative 1x to the negative 2 plus 2 to the negative sine of x. Okay, you make that look a little cleaner. It's going to be negative 1 over x squared because we got to make all our exponents positive. 2 sine of x minus 2 sine of x. Okay. Big thing, easiest way to lose some points on homework or whatever is not putting this f prime of x out front, or if you're just doing, or even the derivative, right? D over d of x. Or not putting all your exponents back to positive. Those two things are easy ways to lose points. So make sure we're taking care of it. All right, now just some extra examples to keep these skills building. So let's look at 5. We got x squared minus 3 over x. All right, always think, what else does this look like? It's x squared minus 3x to the negative 1. All right, so when we take that f prime of x, we're going to get 2x plus 3x to the negative 2. That's going to simplify to 2x plus 3 over x squared. All right, on to 6. Okay, we could just simplify 6 before we even take the derivative. All right, if we simplify 6, we can cancel out that stuff on the bottom. If you take that x2 and distribute it to all the numerators, x squared, you're going to get x plus 4 minus 6 over x squared, right? This cancels all those out, leaves you with just an x, leaves you with just a 4, and then you have to divide the 6 by the x squared. All right, so that equals x plus 4 minus 6x to the negative 2, right? So then when we take our derivative, it's going to be 1, it's going to be 12, x to the negative 3, and we know that equals 1 plus 12 over x to the third. All right, that x, when you take the derivative of just x, you always get 1 back. All right, let's move over to 7. We've got 5 times square root of x minus 6 sine of x. All right, we can rewrite that. 5x to the 1/2 minus 6 sine of x. All right, so we're taking the derivative. We have 5 over 2, x to the negative 1/2 minus 6 cosine of x. All right, simplify that a little bit further. You get 5 over 2 square root of x minus 6 cosine of x. All right, that's your final answer. All right, moving on to 8. Cube root of x minus 4th root of x. All right, the same thing as x to the 1/3 minus x to the 1/4. So we take our derivative. 1/3 x minus 2 to the negative 2/3 minus 1/4 x to the negative 3/4, which in the end is going to give us 1 over 3x to the 2/3 minus 1 over 4x to the 3/4. Okay, that is your final answer. A lot of these look the same. Okay, the big thing is setting it up so you can visualize it, going through your processes, and creating something that helps you view it in steps. That's what I always do, is I try to build in steps. All right, so I can follow that process every time. So now we have 9. First, let's set it up so we have it all in. All our exponents are up top. All right, they seem like they all are already. So when we go to take our f prime of x, we should have 4x to the cube minus 6x minus 6x to the negative 4. All right, which will simplify to 4x cubed minus 6x minus 6 over x to the 4. Okay, so that's it for today. Big things to take away from today's notes is, like I said, make sure you're putting that f prime of x out front in your work. Make sure that you're always taking your answers all the way to the end where your exponents are positive. Do not leave exponents negative. And make sure you do, I say you guys practice as many problems as you can of this. Just go look up different calc problems, watch as many different videos online. This is